Fortunately, madam is my supervisor also. So, madam is associate professor in the Department of Computer Science and Engineering at NIT Hamirpur. She is working in the faculty CSE department since 1991. Before that, for 2 years, madam has served in Banastri Vidyapeeth. She obtained her PhD from Guru Gobind Singh Indraprastha University, Delhi, India, and MTech from Indian Institute of Technology, Delhi, and MS from Vladimir State University, Russia. She has been head CSE department during Feb 2011 to 13. Her major research interests include AI, network security, and software engineering. At present, several students are working under her guidance towards MTech and PhD. Madam Datta held the charge of coordinator video conferencing from 2006 to 2011, coordinator communication 2008 to 2011, and coordinator institute library 2007 to 8. Chairman for library automation committees from 12 to 13. She is coordinator for information security project of DIT and empaneled consultant for IPv6 by DOT. Dr. Datta is actively engaged in the organization of short-term training programs, various workshops, seminars, and conferences. She has delivered several technical talks on various topics related to computer science. She is on the national and international committees of various international conferences and journals. She is the life member of ISTE, CSI, SIG, SEM, and SISGIAL, SIGTIAL. She has published more than 100 research papers in various journals and conferences of repute. Dr. Datta visited Singapore and Australia regarding training under UNDP and Cisco. She has visited several universities during her abroad visits or presentation trainings, etc. Dr. Datta stand for her contribution to the Cisco Networking Academy program in 2001 and Best Paper Award for the paper titled Adoption of Video Conferencing in Technical Institutions, a case study of NIT Hamirpur. That is in the section Annual Convention of ISTE in 2000. So I warmly welcome ma'am to you, and it is my privilege to invite you here, and all the participants will dive into the great knowledge of your area. So I welcome you, ma'am. Thank you for accepting an invitation. Over to you, ma'am.
Thank you, Dr. Priyanka, for giving such a detailed introduction about me. Well, I feel that when it comes to the computer science and information technology concepts, there is always a learning process that we keep on continuing. And as we see that technology changes after every 1 year, 2 year, and we have to keep with the pace of this accelerated technologies. So in a way, we are also we keep learning, and the new technologies that are coming up, we have to share the knowledge about that also. So I thought that keeping in mind about this information, so I'll be covering the topic related to my slides are visible.
Yes, ma'am.
Okay. So after having discussion with Dr. Priyanka, I thought that why not cover the topic related to natural language processing, as nowadays the natural language processing has been at forefront because of these thanks to the technology development in hardware as well as a lot of softwares that have been being developed. So I'll be covering up briefly the topics about NLP applications, which are vibrant nowadays, various tasks that one has to perform in order to get those applications work perfectly, how deep learning is suitable for NLP, and how it has, and what tools are being developed. So it's not that concept of NLP is new, it's quite an old one, right from the 60s, if you see, or 50s, okay, 1950s and 60s, when AI was coined at that time itself, and during the Cold War between US and Russia, USSR, the concept of NLP was vibrant, and a lot of funding was being made available to the various organizations for NLP projects. But the issue is that the success at that time was not that much acceptable, and even the small task of machine translations were not very much satisfactory. So people kept on working even later on. So you will find that there is a hype, and then there is some progress, and then there is a very silent period, and then again there was a progress in 90s and 80s when statistical approaches were being made available. And nowadays when we see but at that time not much of the digital data was available. So your computing was mostly focused on the mathematical computing or numeric computing. So the technologies were developed with the perspective of having the best precisions and all. But afterward, what we see that now when we have a boom of internet technologies, a lot of digital data is being created, and especially in the era of social networking, blogging and all, you find that a lot of textual data, video data, audio data is being created. Now, this data has to be made use if we want to harness, and commercially, organization found that this data can be very much effectively utilized for the benefit of the organizations. For example, the feedback. So, if the feedbacks are being processed properly and are handled properly, then they can be helpful for the organization to take the appropriate measures. Similarly, e-governance, if you see, various all the organizations, governments, they want to make use of these technologies for the betterment of the society and for the implementation of their e-governance projects also. So now NLP is at forefront. There are one reason is that now we have got a very good hardware technologies available which are able to process them. We have got a digital data availability, we have cloud resources, and at the same time we have got an internet of things concept also in picture. So all these are now favorable for the software development in the area of NLP. So this is the most popular domain in today's time, and we are familiar with the concept of machine learnings also. So as we have taken up the concept of deep learning tools, so earlier machine learning methodologies were popular, and various technologies that you see nowadays, like chatbots, voice assistants, and all, they are actually powered with the NLP tools only. So the collection of methods to make the machine learn and understand the language of humans, that is the premises of the NLP. And how you can go about it, you can either develop your own projects, your own softwares, or you can use open source libraries, or you can buy the software as a service also. So you will find that there are several vendors who are providing you software as a service from the NLP perspective. And this is becoming the quite sought after skill by the top companies nowadays. Coming to the industry, all the industries could be benefited, be it a finance, manufacturing, electronics, etc. For example, the classification of reviews based on the sentiments, whether positive or negative. You can count the frequency of words of phrases and perform the topic modeling, that what the content, what is the information going on about what people are talking about. Developing predictive equipment's maintenance schedules based on sensors, text log data. So again, it is a useful information. Labeling and tagging of speech recordings, etc. So domains, as we said, all the domains could benefit from the NLP: healthcare, defense, financial, governments, environment, etc. Okay, what they can handle, they can analyze the public feedback, they can improve the prediction, they can improve the regulatory compliance, and they can also perform the policy analysis. So this has now this finds a lot of acceptability in the systems on the organization. So you can see that the different capabilities are there, which are there for the organization to harness: text clustering, information extraction, named entity resolution, relationship extraction, sentiment analysis. So you can see that all these applications are very much suitable for any other organization. So that is why you find that people having the NLP skills, machine learning skills, they are being sought after by the industry to a greater extent. So some of the applications which I have taken from the literature. I've mentioned here the paper. They have mentioned here the topic modeling, for example. So they can uncover the hidden topics. For example, this was the use case which was reported. U.S. Security Exchange Commission made it foray in the natural language processing aftermath of the 2008 financial crisis. So what they did, they went through the documents and tried to find out what was the potential problems in the disclosure reports of the companies. So the companies were reporting certain things and which were not correct, and they were able to find a lot of flaws by using the NLP techniques and exploring those documents. So they used LDA technique, and they saw the customers' complaints and comments related to one another. And what was the problem there? That they had more problems about the mortgage complaints containing allegations of racial discrimination. So if they found that there was a misconduct, then they could take action accordingly. So for government, it was possible to take the action based on the application of these NLP to the documents of the financial documents of these organizations. Now, next is the text categorization, as we have specified. So in text categorization, what we do, we create a specific categories and specific taxonomies. And this is the taxonomies could be defined by the human itself, and it could be one category, it could be two category. If it is one only, then nothing is to be categorized. But after that, binary categorization and so on. So, for example, you're categorizing some certain tweets are there. So you want to categorize whether they are pro candidate or against candidate. So this was used. Okay, now this is the application that the classification of sensitive information. So research studies used NLP and machine learning on nearly 1 million declassified diplomatic cables from 1970s to identify the features of records that had a higher chance of being classified. And this was the thing which they carried out. So they found that there could be certain information which could be classified or which could be declassified as a bigger concern for the government. Text clustering. Now, text clustering and categorization are two things. So in categorization, what we do, we specify the categories, whereas in text clustering, the grouping takes place by the discovery. So by finding out the patterns in the data sets, the algorithms you apply, clustering algorithms you apply, and then find out the similarity in the contents, and they would be put into some particular groups. So this was carried out by the Center for Tobacco Products and part of the US Food and Drug Administration. They use the text clustering and topic modeling to group the documents based on specific key terms. So, for example, the topic menthol could form one cluster with those concerning menthol used among youth representing a subset. So if something is being used by the industry for their production, it's one thing. If it is being used for another category, then it is naturally another problem which they have to address. So for what purpose it is being used? So they use a text clustering approach to figure out this information. Information extraction. Now here, this application means that we have to find out the meaningful information from the text. Now text is unstructured data. So how do you really find out the meaningful information? So for that, you apply the information extraction algorithms. Now, for example, one potential application which was reported is a transparency and accuracy in crime reporting. So what actually happens that in the crime reporting, the information gathered during the reports and all while writing the reports, the crime witnesses, victims' accounts are normally incomplete, and they could be due to different reasons. So they found that they could comb through the witness and police reports and related news article to identify the crucial elements that what was the that appropriate information which is actually required in these kind of scenarios. So information extraction is another application which is very, very much suitable for the organizations. Named entity resolution. So here in named entity resolution, what we do, we extract the names of persons, places, companies, etc. And we classify them into predefined labels, link the named entity to specific ontology. So anything which is there in terms, so normally they are the noun phrases, nouns, or even the pronouns references which are there, they have to be tackled here. So text will contain references to different entities, and they have to be gathered. Now, if you see, for example, here, Georgia is mentioned. So Georgia is a place which can be a nation, it can be a state also, and now it has to be resolved appropriately, whether it's a state or it's a nation, US state or a nation. So extracting named entities for various application is also very, very important thing. So relationship extraction is another application. This capability helps establish semantic relation between the entities. So if you have certain information, and semantic relation, identifying semantic relationship helps in creating, is useful, for example, in your search engines also, that you want to have a correct interpretation for the search that you are performing. For example, if we are using the word cricket, okay, for us cricket means a game, but in another domain it means a hello. Sentiment analysis. So sentiment analysis is another application.
Yeah, all of you are requested to please mute your mics.
So sentiment analysis, of course, is another application which allow agencies to analyze and interpret citizens and business comments. So here, what people are writing in the blog, in the tweets. So examining these tweets or various write-ups helps in understanding the information which is required by the organization or the governments also. So how people are really using the services, what is their feedback. So sentiment analysis is another application which is useful for the organization. Now, all these applications, it's not that they are new. People have been developing the various algorithms, rule-based algorithms, and then statistical methods, and then machine learnings. And we will be working through the deep learning, reason being that that other previous methodologies which were there, they had the limitation that they were not able to handle large amount of a data, or large amount of a data was not available. And there are other things that we'll just see. So machine learning is the first step toward our manipulating this textual data or unstructured text data. And machine learning, what it does, that it try to learn the patterns in your data, and we do not program. Okay, we do not write the program, but the algorithms that we apply, they try to learn from the given data. So you have got a label data. So label data means that this labeling has to be done by some experienced users, and then we apply the algorithms, and we have got certain models. We apply these models, okay, and uh, by applying these models, we want to predict that if this is the label data, whether this prediction is correct or not. So method that can learn from and make prediction on a data is actually related to your machine learning, and you must be familiar with various machine learning algorithms by now. So learning naturally has got a different way, and as a human being, we also know that how we learn things. So we broadly in machine learning, it is categorized as a supervised, unsupervised, and reinforcement learning. Supervised learning is like you're learning by with the help of a teacher. So some training is there. We specify the things very well beforehand, and then they are classified. So for example, this is a classification of a text into class category A, class category B. Whereas in case of unsupervised learning, we try to discover the pattern in the unlabeled data. So this is a labeled data and this is an unlabeled data. Supervised learning relate to the classification. So some, for example, the emails are already labeled as a say, spam or not spam or some other category. So accordingly, we classify. Classification is a supervised learning approach. Clustering here, the patterns are unlabeled. So we have not labeled them into particular category, but clustering algorithms, they will find out the similarity between the documents. So we have got different functions to identify the cosine similarity and other similarity measures you will be using. So they can be clustered into different categories. Okay. Next one is your reinforcement learning. So this learning takes into steps. So here we learn to act based on the feedbacks or the rewards. So, for example, you will play a game. So initially, you may not be very familiar with that particular game, but later on, when you keep on doing it, okay, keep on playing, you are able to learn, and then you are winning or losing, and that way you are able to learn the games also. So with the practice or with the subsequent steps, you are able to learn it. So basic difference between machine learning and deep learning is that here most machine learning will, because it is a human designed representation. So whatever data sets you have, say whatever features you have, they are defined by human beings. So that means that if you're defining, then in that case, you're define and the way you define, okay, the results will be accordingly good or bad. And if the data set is very, very large, there is a likelihood of making mistakes also in that process. So one thing is that you have to identify the features, you have to create the feature sets, you have to create the labels, and in that process, it all depends on the human's specific competencies. So describe the data with the features so that the computer can understand. Algorithms are there which will actually be working on the parameters. So how you are actually modifying the weights, increasing or decreasing. Okay, so you are applying those things and then you are working on the problem. So this is a case of the named entity recognition. What features are there? You will need to have a current word. You need to have a previous word. So set of features you are identifying. So based on these features, you are working on the named entity recognition problem. In case of a deep learning, so in case of a machine learning, you give an input, you do the feature extraction, and then the process goes on. Whereas in case of deep learning, you give the input, but the deep learning process, okay, the feature extraction plus the classification takes place by the deep learning algorithms itself. You can see here that your deep learning neural network, and again, because deep learning architecture basically is a extension of the neural networks only. Okay, so if it is a deep learning is a subset of machine learning, where artificial neural algorithms are inspired by the brain and it learns from the large amount of data. So earlier neural network models, okay, they were using primarily input layer, output layer, and hidden layer. So at this point of a time, the link carries signal from one node to another, boosting or damping them according to each link's weight. So this was architecture followed during 1980s. But now the deep learning neural network makes use of several hidden layers. Okay, so there are multiple hidden layers. Okay, there are multiple large number of input layers, and there are also large number of output layers. And these very large number of hidden layers, okay, they are actually helping you to solve the complex problems. Now, deep learning, if you see, okay, why it is now being preferred. Okay, one thing is that in machine learning, the feature set which we are designed manually, they could be over specified, they could be incomplete, and they can take long time to design and validate. So this was the problem, that it required a lot of human efforts. And naturally, you have millions of data and terabyte of data which is being generated today, if you want to work upon them, naturally it is very, very difficult for a human being to really work correctly. And learn features are easy to adapt and fast to learn. Okay, that is what is there. Deep learning provides a flexible, universal learnable framework for representing word, visual, and linguistic information. Now, deep learning was has shown great success for speech and vision. If you see the image processing related applications, many applications have been successfully handled by the deep learning. And now it is also showing good success for the NLP also. The growth, if you see, okay, this blue line is for the machine learning, and if this is the red one is for the deep learning. So deep learning in early is okay, 2009, and at that time it was not very popular, so it was growing slowly, but it was now it has gained a lot of popularity. But you see that machine learning algorithms in literature are still popular because people find that the data sets which they are working, they have to be pre-processed also. So, so managing the data sets is one of the critical issues still here. But you will find that many data sets have been created, which pre-trained models are being made available, which can be used for your task also. So generalization, which you find that universalization, that is helping a lot in use of the deep learning technologies. So when you want to apply deep learning to natural language processing, there are different things that one need to understand. So one is that how you are going to represent your data set. Okay, how the text has to be presented. Now text, if you see any text that you have, it consists of at the basic level you have a characters. Okay, and character forms the words they form the sentences, and sentences they form paragraph, and with the set all this collection of paragraphs and all they form a documents. Now how are you going to represent, first of all? Okay, then there are how you are going to get the solution to the problems by using the deep learning. So there are different architectures that we'll see. Okay, that to different problems like your information extraction, summarization, machine translation, and all. So naturally now for those we want to apply deep learning architectures. So first step is actually the representation. So in NLP, if we are using neural network, okay, so words have to be represented. So generally the words are represented as vectors, and traditional approach is a one-hot vector. Now one-hot vector means what? That any word that you are representing, okay, will be represented by a set of bits, okay, and it would be of some length, okay, and in all the position it will have zeros, and it will have one in a position where the word ID is to be referred to. So if by this particular method, when you're using, okay, so suppose if you have a word you want to represent hot itself, okay, and the vector consists of 10 bits, okay, so in one of the position it will be 1, and in rest of the positions it will be equal to 0. But if you have a word say cold also to present, then in other position it will be representing 1, and all other cases it will be 0. So what we see here that when we are using one hot vector representation, the word meaning is not captured. There is no understanding that what the meaning is there. It's only the word representation. And the words such as English and French, cat and dog should have a similar vector representation, if you see, because English and French they are similar, and cat and dog are similar. So if they are similar words, so similarity between these two words have to be reflected. But if we are using one hot vector, that cannot be captured. So similarity between all one hot vector is same, so that no differentiation is there. So this is the limitation of one hot vector. So it says the distributional hypothesis says that words appearing within similar context possess similar meaning. So if we have to use this particular hypothesis, so we use the distributed representations, and this distributed representations is learned through the context. So what in context they are being used, we use that information for identifying the embedding for the words. So distribution chosen so that similar words will have a similar distribution. So the model which was proposed in 2003, okay, by Bengio and all, Bengio and its colleagues. So they represented a vector representation of each word and parameters of the probability functions in its parameter set. So here if you see, you have got a word, word index t minus n plus 1 and ti minus 1. So this is all set of words which are there. And the model find out the parameters that minimize the perplexity of the training data set. And model will eventually learn. Okay, so it will learn the representation for each word with the probability function. That WT is a representation is equal to I given the context. So from the given context, it will identify what its representation has to be there. So neural word embedding, if you see, okay, you can represent words, you can represent phrases, and even the sentences using these embeddings. So it all depends what you want to represent. You can use the words representation, you can use a representation for a whole phrase itself, and there are different libraries also which can be used. So this is a example. So this is a so this is example which will just come back there. Now this the embedding that we talked about. Okay, if you're using word embedding, right? So the issue will be that generally from the text, okay, uh, there could be in real world text there is people don't follow the specific pattern, and there could be misspellings and different slangs also. And nowadays we find so many new words which are being written differently. So how they will not be captured here? That is a problem. So you have got a this particular software, that is a globe. Okay, this is a global vector for word representation which has been developed by Stanford. This is an open source. You can use this particular model for distributed word representations also. Okay, so to handle this word representation, okay, word-to-vec model has been proposed, which consists of two concepts. One is your CBOW, continuous bag of words, and flipgram model. So you have got a words given here. Okay, so you have, say, for example, this is the words context is given. Okay, so for example, two words before, two words afterward, and then it find out the embedding for the word within the context. Okay. So CBOW, what it does, it constructs word embedding, and the objective is to compute the conditional probability of the target word given the context. So it gives a context for a given window size, and it finds out what the embedding will be for a given word. On the other hand, skipgram, what it does, it takes a word and it identifies the context. That what is the context in which this word is actually will have this one. Okay, so it constructs word embeddings where the goal is to predict the surrounding context words given a central target word. So a word is given and it will try to generate its context. So word to vector is a representation which is normally used in deep learning. Okay, so we wanted to see the code here. So this is a GenSim library which is available. So you can use the GenSim library. So if you want to use the deep learning, the familiarity with the Python is also very much required. So what we do, we first of all import from GenSim model, we import the word2vec library. And we take set of sentences. I'm just sharing this code. Hopefully it is visible.
Yes, ma'am.
Okay. So thank you. Thanks a lot. So we take, how do we work with the convert this word?
Actually, yeah, ma'am, do you want to make us see the code?
Yeah. Are they
No,
participants?
madam. The right now the slide is there, which is being shown. That is challenges with word embeddings.
I want to show the, so sure. Where do I have to go?
Hmm.
Okay, so how do I show it?
Might be, ma'am. You just go back and then share that, not the application actually. Then a whole window you have to share, and then go to that drive where it is in that way.
Okay.
Like, I think that you have to stop sharing first, because you have been sharing an application, this
Okay,
PPT,
so
no?
I stop this one.
Hmm.
I
And then
share
the whole
code.
window.
Okay,
Yeah, ma'am.
I share this one. Okay, code. Okay, so I think that's okay. I think, right?
No. Yeah, ma'am.
Okay, so we were talking about the word this embedding. Okay, how do we do the embedding for the words? So word2vec is a model that is available in the GenSim library. You can import this library, define the training data set. So suppose here we have the set of sentences. So we define king is a strong man, queen is a wise woman, boy is a young man, and so on. So this is a library we are using, and the set of sentences for training we are considering. Uh, so we develop the model, word2vec model. We take the sentences, all these sentences, and we define this model. Okay, we generate the model. Okay, so then we list the vocabulary. So when we just specify the vocabulary for this one. Okay, so vocabulary generated, and so word2vec vocabulary. So we specify that they are 17, size is 100, and the alpha rate of learning is 0.25. So the vocabulary generated is king is a strong, means all words are generated here. Okay, and the corresponding encoding, okay, which is used for these words is also generated. So if you see, this is a array which has been generated. Similarly, what you want to now, this is what it has learned. We can do the decomposition, import PCA, and we can see the two-dimensional representation for these words, okay, how they are being encoded, okay. So if you see, this is, if you are using PCAs, okay, this is how they have been, word embedding has been provided by using the word to vector model. So if you see some words like woman, prince, they have been placed closely, okay, prince, king, man, they have been placed in vicinity. Then there are words like A, B, they are quite far. Pretty is somewhere here and young is here. This is the representation if we have used PCA component to vector, two variables we are using. So now we take another method, just improvement. So we remove the stop words. We had the stop words here is A, B, etc., which are not very much useful. So they have to be removed. So we now define again, and we take the corpus. Now next step is remove the stop words. So all the stop words are removed from here. Okay, and words now left are only the relevant one. Okay, so all stop words which have been listed here, they are already removed. So after that, what we do the data aggregation part. Okay, and so we now create the data frames. Okay, so king, strong man, queen, wise woman. This is what is now created as a pair, and we now find out the relationship. So the new label heads have been generated, like king, strong is a label, king, a man, strong king, etc. Okay, so for all the words, if you see, the labels have been generated. Now we want to generate the encoding. So it generates the encoding in an integer form. The boy is 6 and so on. These values have been generated. Now we want to see a graph. Okay. So two-dimensional visualization, if we want to see for a vector, this is a vector table which has been generated in a 2-dimension. For like queen will have these values, strong and so on. So all the words which you see here, they have been assigned encoding. Okay, and correspondingly chart, if you see, this is a chart which is now generated. So if you see here now, different encoding is made, is given here. So if you see women, queen, young, king, boy have been placed here, girl is placed here, and so on. So this is how you are able to use the uh, encoding, use the GenSim library to encode your words. Similarly, you can have a vector space model representations also. Fine. So
In the same way, ma'am, yeah.
okay, I think now it's okay. So it won't move. Screen share करना चाहिए इसका मतलब. So the word embedding, you can use the available libraries. What they do, we took set of sentences and they try to relate them. Okay. So for example, here we take the document one where some text is there, another document, okay, which shows that Obama speaks to the media in Illinois. The president greets the press in Chicago. So similarity means that similar words should be placed in a two-dimensional space. They should have an embedding closer to each other. Okay, this is what is the idea here. Now, when we are using word embedding, what we find that there are certain issues there because polysemy, etc., they cannot be handled there. And if there are words which have been written incorrectly, also their embedding will not be done correctly. So another way of providing the embedding to at the first level is the lowest level is a character embedding also. And there are several languages, like even our Indian languages, if you see, they have got a lot of inflections. Okay, they are morphologically rich languages. So all the morphologically rich languages, okay, they result into a different set of words, and they have similar kind of similar meanings, but they are written differently, slightly different. So how they have to be really captured? So for that, it says that character embedding would be a better idea. So if we are using a character embedding, then even the case of the out of vocabulary word will be good enough. Okay, so this character embedding, see if I can. My screen.
It's visible, ma'am.
It's really happy. The thing I want to do. Okay, so this is it visible? Yes, I think.
Yes, ma'am.
Okay, so I'm just showing how Google is using the character embedding. Okay, they have got a good tutorial here, which they have done for a billion words language model, character embedding model they have used. Okay, so how they go about it? Okay, for example, here it takes the model where it takes the probability of a hello word. Okay, for this one to be there is nothing but a product of a, this is a start symbol and this is a ending symbol. So it takes the product of what? Product of all these probabilities, that there is a probability of a start symbol and probability of a hello given S, then probability of a word, and given this S and hello combination, and probability of full stop and so on. So this is how they have developed, represented the probability of a sentence like hello world. Now for character embedding, okay, so they have used the character CNN stage, okay, like this, that it takes the word, say suppose THE, okay, the, and what is the probability that the word the cat is to be there. So it takes the character CNN stage, okay, this is the character CNN stage. It takes raw characters of the input word and produces a word embedding. And the yellow one is your Lstm model, okay, which takes a word representation with its states vector. And this is a softmax layer, which learns the distribution, that what is the vocabulary going to be there. So you have got a word characters which have been defined, and then it generates the next embedding for the character. Okay. So now character level embedding, if you see, okay, the representation in a one hot is like this. For A, it will be something like this, okay, 1 and all zeros. And for C, it is 1, 0, 0, 1 and all. So 26 alphabets, so first alphabet 1 and so on. C, third alphabet 1 and rest all are 0. This is one hot encoding which is there. So naturally this is, embedding is very cumbersome, okay. Now, how it represent, okay? The character alphabet is suppose of a, is of a first layer of character CNN component. The model is responsible for translating the raw characters of the input word into the character embeddings, which are passed through the convolution filters. So, character alphabet is of size 256. Okay, non-ASCII characters are also there. So it is alphabet. हमने जो लिए, what we took is 26, but encoding, if when we do in ASCII, then they comes out to be around 20 into 256 bits. So they all have to be encoded, and they encode into the dimension of a 16 here. And A, for example, will be represented like this. So this is the value for A representation. So this is how it shows that how the characters, the words which are there would be having the representation. So this shows for a 2D projection of our embedding space. This is the embedding space for 2 dimension, and then they have generated it for 16 also, 16 dimensions. So this is so you can use character embedding, you can use word embedding, okay, and you can use a globe also for GenSim libraries, and these are different frameworks which you can use instead of developing your own embeddings. You can use any of these frameworks like space, semantic vectors, GenSim, etc. FastText. Naturally, conversion with the language Python is something important here. Now, as you see that these conversions are being done by the deep learning models, okay, deep learning architectures which are there. So, we first of all, for embedding CNN network is popularly being used. So, for word embedding, for representing the word, this is one of the common approach to develop your embeddings. Okay, so what it does, tokenize the words. Okay, apply the convolution filters. Okay, and you apply the filters for a specific window size to create the feature map, and then follow the max pooling operations, and then you generate the sentence. That means your sentence encoding can be obtained from the word encoding, or you can have a first one as a character encoding. So you start. So sentence embedding can be obtained. Final sentence representation can be obtained if you are using the CNN architecture. This is the model which has been provided by the Colabert and Weston. You can see that this is a sentence. I love this movie very much. So for that, you have an input embedding sequence of a sentence. Then you apply filters. Okay, you apply the filters, and these filters will generate a multiple feature map, apply the max pooling, and then you apply the dense layer and softmax layer. So this architecture is used by the Colbert and Weston for generating your sentence embedding. So now, if you are using CNN, okay, so if you're using CNN, you can use a you can use a window-based approach also, okay. And for each word, a fixed size window of neighbor words can be considered, and then you can tag a word based on the neighboring word and perform the embedding here. Okay, so window approach can be used for CNN architecture. But then you have got here a limitation that the size of the sentences is going to be limited here. Fixed window or surrounding itself is assumed, and the subsistence ranging within windows are only considered. So predictions are attributed to the words in the center of the window. Now CNN, if you see, okay, it has got a limitation, and if we recall our text data and all, they have got a relationship among each other. If there is a one sentence and there is another sentence, there is a relationship between them also. There is a relationship between a paragraph to another paragraph also. So it results in a long distances dependencies. Whereas CNN doesn't remember any of such dependencies. It works on a present data. It produces embedding for that one, and that's all. After that, nothing is available. So, and another thing is that vectors are of a fixed length. So that is a issue here, that CNN is suitable for certain applications where you are looking for just one word answers and kind of those applications. You want to do a classifications and all. But if they want to figure out the long distance dependencies, then this kind of a network is not enough. So normally people, they combine it with another architectures like time delayed neural networks, the dynamic convolution, etc. So for NLP applications, CNN is limited for, say, word embedding kind of applications and all, where limited applications you can handle there. Okay. So another one where you want to handle the long sequences, okay, RNN architecture, that is recurrent neural architecture, is preferred. So it uses sequence of information, which says that we are doing the computation over the steps, applying through the sequences, and outcome is a fixed size vector is produced to represent a sequence, and RNN, they have a memory. So such kind of architecture is suitable for NLP tasks. So if you see here that the RNN framework, okay, so you have got inputs here, okay, and these are processing units, okay. So their outcome is passed on to the next layer also. So it is a connectionist model having a memory. So what you have, input is there and there is an output. In CNN, you do the operations here and they are passed on to the output layer. Whereas in case of a recurrent neural network, we are adding up the outcome which is there, HT, which we are giving, we are passing on, we are receiving input from the previous layers also. So we receive a input from previous layer, and that is helping us in training models. So training RNN requires what? It makes use of back propagation through time is used to learn in the RNN. Okay, so the delays which we have included here, they help us in learning process through the back propagation time. Fine. So error at each time step we are getting, and they are added up at the next step and passed on to the next layers. We can use different variants of RNN, and our Lstm is one of them, which consists of input, forget, and output gates. We have got another architecture that is GRU, okay, gate recurrent units, okay, and residual network is another architecture which is used popularly for so long short-term memory, if you see, it has got a more number of units, whereas gate recurrent unit has got a smaller set of memory units. Okay. Further extension is a bidirectional recurrent unit you can have, which depend on the current state on the previous state, and we are going to extend the model dependence on both past state and the future state. So it's a bidirectional. In bidirectional, past and future, both states are considered for your output. Okay, So Lstm is one of the popular architecture which is used in NLP tasks. Okay, having what it has got. It has got a input you are performing, and then there is a memory which is computed, and there is a forget gate which says that these are the components which has to be unlearned also, and based on components what you have to learn and what you have to unlearn, based on that you create your outputs. What applications can be there based on the Rnn architecture? You can have a word level classification. You can have a language modeling, sentence level classification, semantic, NLP, natural language generations, like the tasks like machine translation, visual query, question answering, image captioning, etc. So if you want to handle these applications, Rnn architecture would be more preferred as compared to your CNN architecture. Now, machine translation, what you can do here, that you have got a sequence of words, okay, in a source language, and you want a outcome in a target language. So for that, you can use an encoder decoder architecture for machine translation, where you use the input words. Okay, they are passed on to the RNN. RNN will encode them. Okay, and then decoder part will actually generate the outcome, the translated target language. In visual question answering, it is given an image and a natural language question about the image. So it combines image here. So this is a picture from Antols et al. 2015, which there is a question is, what is the mustache made of? So here the mustache, if you see, is made up of banana. So so your model should be able to figure out that it's not a mustache, but it is a banana. So visual question answering is another application where RNN you can use. Now, another RNN-based framework where decoder is slightly modified. So here it used the last hidden state along with the information calculated based on the input hidden state sequences. So what was there earlier in the input sequence, that is also utilized finally at the last stage also. So this is known as the attention mechanisms. So this is another model which is popularly used in NLP applications. So if you see here, this makes use of attention part, and this is added in the last layer. Another one is your recursive neural network model, which is similar to your RNN. And if you see here, what it does, it takes the recursive structure where words and subphrases are composed through the they compose other higher level phrases in the hierarchy. So if you have got a not very good as a base level, so you combine very good first of all, and then you combine the recursively the another word also, and find out it's the probability. Different variants are there, and naturally when you are working on, you will be able to explore them in details also. Okay, where all you can use recursive neural networks, especially good for parsing applications, sentiment analysis, relationship classification, and sentence relatedness. So these are the application where recursive neural network would be suitable. Then you have a recursive auto encoder. Now here, the recursive auto encoder part, it takes the application of recursive in a binary tree form, and the nodes which are not filled are only used to compute the reconstruction error. So this is a standard encoder is modified into the recursive auto encoder. This is how it would look like. I walked into a park car, so it combines, and then it combines the next one, create the semantic representation, and then it predicts the semantic distribution for the words. Now, semi-supervised training is another model which could be used in your applications. So here the autoencoders are trained with two objective function, and output is at each level of the tree is fed to this model is there. This is a semi-supervised model that you take the weights, okay, and reconstruct the error, reconstruct your cross entropy errors. So this is different architectures are there which you can actually use. Another one is your reinforcement learning. So this is a approach where trained agent through the discrete action through the reward and models. Okay, you have got a agent. Okay, it looks at the environment, observations are there, and accordingly the actions are taken. And if the action is positive, then naturally it will be rewarded. So your rewards and all approach could be policy based, which can search directly for the optimal policy, and policy achieving the maximum, which the reward is could be the approach. Another one is that you estimate the optimal value function. So and based on the value achieved under any policy, you would be actually performing. Third category is a model-based reinforced learning, and you plan according to the model that way. Unsupervised learning, if you see, has got a fixed size vector, distributed representations, skip through model. So sequence to sequence frameworks are used. They can be models can be used here. And another one is your deep generative model. These deep generative models, GAN architecture, variational and autoencoder, these are another architectures which are used in our applications of NLP. So this is a case of a variational and architecture here. GAN is it is composed of generator and discriminator. So you'll find that several applications could be handled by this architecture very in an effective manner. For example, deepfake kind of deepfake news that we deal with today. We want to identify the applications which are not correct having the correct information. So GAN architecture could be a good one there. So what it does here is that you have got a generator and a discriminator. So generate will generate a false kind of a thing, and a discriminator component will try to discriminate whether it's a true or a fake data here. So real data is there, so it should be able to discriminate between the real data and the generated samples. So this is the beauty of the GAN architecture, which is now popularly used for spam detections and all. Then you have a memory augmented networks also, and a range of architectures are there. Okay, so this is autoencoder that we have discussed earlier. This is a deep autoencoder, which says that here the autoencoder, if you see, has got layer 1, layer 2, layer 3 only. Okay, so it has got an encoder, and hidden to output corresponds to the decoder, whereas deep autoencoder, they will have a multiple hidden layers. So this is the difference here. Now, after considering different architectures, okay, one thing is important that a person should be familiar with the programming language. One is the Python. Uh, Java comes in handy, and understanding of C++ is good for developing the optimized solutions. Okay, so if you're concerned with efficiencies and all, the C++ gives you better control over your application development. Okay. Java naturally gives you a visualization kind of application handling in a better way. Python has got a large library, so it is supported by most of the developers. So Python is most preferred language for deep learning applications. You can use already available platforms also, rather than getting into the details of the deep learning architectures and frameworks. You can use several platforms which already provide you the ready-made solutions, and you have customized according to your applications. So this is being what done by many of the organizations. They make use of these existing platforms. For example, Monkey Learn, you can visit their site. It has got rich repository. Alien, IBM Watson. So all big names, if you find that they are now providing NLP solutions. Core NLP is from Stanford Group, Nltk, okay, TextBlob, Gensim, Specky, or these are all different platforms which provide you large number of libraries. Now, TensorFlow, okay, is one of the platform which is provided by Google, so which is maintained by Google, and if you are using its repository like Gmail, etc., okay, they are being supported by TensorFlow only. And they have been adopted by Intel, Airbnb, Twitter also. And the repository, since it is offered by Google, so you'll find that a lot of resources are available online, and it is supporting different languages also. It is also able to integrate its implementations along with Keras libraries also. So if you want to use TensorFlow for your application, this is just one example how you will be using its TensorFlow libraries. For example, the word embedding itself, okay? So you can use the TensorFlow library, neural network model, and then you can specify the embedding, okay? So embedding lookup. And if you want to use the TensorFlow on your platform, then you just have to install it by using pip install TensorFlow. This is an example of a sequential model, how you can use the TensorFlow with along with the Keras library. So this is a layers which we are defined. First layer. So first layer is your flatten. So it takes the input, okay. So it specify the image, okay. So this input layer. Then it specify the next layer, which is a dense layer, because we have specified that here dense or fully connected layer, next layer that is being specified, and last layer is your output layer. So it is specify what is the activation function. Okay, for example, here also the activation function has been defined as a relu, and for last layer it is a softmax function. Here also dense model we have used, and here also we have used the dense. That means all the layers are fully connected. Okay, and we specify how the model is actually organized. So it is a sequential model. First is your layer 0, layer 1, and layer 2. Thereafter, we specify the model, its optimization function, what is the gradient function that we are using. So Adam is a model function which has been specified. And how are we measuring the performance through the accuracy? How many epochs are specified? Okay, so that also has been specified here. And then we specify the prediction label also. Okay, so this is an example. Import TensorFlow as TF, and from Keras pre-processing text, import text to word sequence. So from a text to word sequence, this is a pre-processing library from Keras that we are using. So suppose this is our text, the quick brown fox jumped over the lazy dog, and we take now the outcome is taken here, the result, we present the result. So this was a sentence which has been tokenized as a individual word here. Okay, so this is a tokenization process by using the Keras preprocessing library in TensorFlow. This is how you are going to write. So I put here a link also. You can visit these in TensorFlow libraries in the Colab. You'll find a lot of codes which you can use it. Now this is an encoding with one hot. So we have studied the one hot representation also. So from Keras preprocessing text, we import one hot now here, and import text to word sequence as such, the one which we have done. And we set the text to word sequence for the text, identify the vocabulary size. Okay, so vocabulary size is 8 here, and we generate the one hot embedding here, and it prints the result. So it has got a vocabulary size 8, and this is the one hot encoding for the words which are there for each of the word. Okay, so here it was the quick brown fox jumped over the lazy dog. So for each of them, it gives you the one hot encoding like 5, 9, 8, 7, and so on. Now all the TensorFlow, if you want to work on the TensorFlow, the advantage here is because it is supported by Google and it is available, you can use it easily. Okay, and a lot of documentation is also usable. So people who want to work with the deep learning, want to venture, they can go start work with the TensorFlow. Another one is your TF Learn. Okay, so TensorFlow Learn. This is a higher level APIs for the TensorFlow. It has got higher level models are included here. Okay, convolution, Lstm, and so on. So all the models you want to use, then you have to use TF Learn. Now PyTorch is another platform which is developed by Facebook, and it use of CUDA and C++ libraries. Okay, so So PyTorch is another good platform which you can use. Okay, so you have to install it, PyTorch NLP, and you can visit the PyTorch site and you can access its repository easily. Theano is another platform. Okay, and this is another platform which you can use, but those two are the most popular one. Keras library is the rich library of the neural network APIs, and it supports multiple GPU training. So if you want to parallelize your architecture algorithms, then they are very good solutions. Okay, this is how you can use Keras. From Keras layers, import convolution 2D, max pooling 2D, flatten. You can use embeddings, which is dense, import the model sequential. So this is how you can use the Keras. Trainer is another platform, but just I saw now, this was also one of the good deep learning model framework, open source, supports CUDA, supports GPU also. But what I found that this has been blocked by Government of India as per IT Act. So this site, this particular platform must be having some certain problem. So I would advise not to venture with it now. Okay. So because earlier it was available, so I have put, but recently when I checked it, it has been blocked by Government of India. So another platform which you can use is your Stanford Core NLP. Again, this is a very rich repository. You can use this one, can perform various tasks like part of speech tagging, pattern learn parsing, recognition, and so on. So wonderful library. You can try this also. Okay. This is combined with the NLP toolkit, grammatical analysis tools, supports number of languages. This is another advantage that any platform should have, that it should be supporting different languages also. Nltk is a toolkit which can use having 50 corpora, lexical resources and all. And again, it is a free and open source community driven project. Now, Nltk, if you are using, you can just use import Nltk. For example, we take here tokenization, how you can do sentence. This is a sentence which is there, and you can use Nltk.word tokenize the sentence. You can generate the tokens. Okay, you can tag the tokens also with a part of speech tags, and it generates the tags also. So it has got various tools of which are required for NLP tasks. This is another activity that we can perform in Nltk by using its library, Nltk chunk. So we use the stack component, and entities shows the complete named entity tree. Okay. So you have a sentence at 8 o'clock on Thursday morning tree. This is for person. Okay, person. This person is there. Arthur is a person. Did not feel very good. So Arthur is a person. So it is able to identify the named entities also. So here, this one is a person. You can show the parse tree also. So tree bank parse sentence, and it will generate the complete parse tree also for you. Text blob is another software which you can use. Okay. So it can be used for NLP various tasks again. This is example. You can install the text block. Okay. Create the text block, take the sentences, perform the part of speech tagging. You can perform the sentiment analysis. Okay. And it will generate the polarity of a given set of sentence. It can detect the language also. Okay. And it can classifiers are also there. So this is again a very rich platform that you can use. So because text block is built on top of Nltk and pattern, therefore it makes simpler. So it offers a lot of things. Okay. These are the activities which you can perform by using text block. GenSim, we had seen, okay, this is a library for document similarity analysis, and it can be used for in your applications. Okay. PESI is another platform. Lot of language support and features are there. Okay, and all the framework that we have gone through. Okay, among them, if you see, in 2018, TensorFlow was most popular, and then comes your Keras, and then comes your PyTorch, and the rest others. So this is the scenario that TensorFlow is very, very popular even today, and they are able to combine it with other libraries also. Now, this is something which you can use the platform, but developing the whole model from the scratch is again a difficult task, and having all the data sets also very difficult. So for that purpose, pre-trained models are also available for NLP. Now these pre-trained models, they transfer learning to new tasks with the already pre-trained models like your GPT-2, BERT, and Elmo, etc. So different models are already available. They have been trained on a huge data sets, and from there they are now being, you can apply in your own applications. Okay, so GPT-3, this is a NLP model created by OpenAI. It is based on the transformer. Now if you see the number of parameters, 175 billion training parameters were sourced from Common Crawl. Okay, Microsoft's Turing energy model was trained on 17 billion. So GPT-3 has been trained on 175 billion training parameters. So this is something very huge. So if you can use these already all these models for your applications also. For example, using GPT-3, okay, human this text was generated, okay, and this was believed to be written by human, whereas this has been generated by GPT-3 only. BERT is another one, which is a bidirectional encoder representation. Pre-trained model developed by Google. So this is another model which can be used. They have got different types. Okay, this is a BERT base, BERT large, which has been trained for on 800 million words. This has been trained on 2,500 million words. So they have been trained on these large sets, and this has been bidirectional using unsupervised language representation, pre-trained on the plain text corpus. So it is able to handle GLUE, General Language Understanding Evaluation task set consisting of 9 tasks. So it has been tested on these 9 tasks, and this has been termed as a GLUE. Then it has been tested on SQUAD, that is a question answering data set. It has been tested on situation with adversarial generations also. It is supporting around 70 languages. So you see your Google search engine and all, email, Gmail, etc. They are being supported by BERT now. Another one is your ExcelNet, okay, which has been created by CMU and Google. So this is again performing something better. Elmo is another one which has been generated by NLP. Okay, so they are using BiLM models. Robert is another one which has been introduced by Facebook. Okay, and is retrained of BERTA with improved training methodologies, 1000% more data and computer power. This is what they are claiming. Okay, so they have more the data they are considering, and this is another one. This is a you can say a reduced version, so distilled version, approximate version of BERT, retaining 97% performance, but using only half the number of parameters. So if you see the number of parameters they are used is very large, whereas now in case of, and there are different mobile BERT and so on are also the different models which are being generated. So again, this is the one which you can use. So there is a comparison you can go through that BERT uses base model 110 million, larger one is 340 million, distilled BERT uses 66. Okay, training time, Then what is the performance data which is being used here? The same set of data is being used here, whereas Robota is able to use much larger. It is using bidirectional. It is using bidirectional without NSPs and so on. So these are comparison which you can see that how they are performing. Now, whatever we have discussed so far, the use of deep learning has got certain limitation. One is that it takes time to train, okay, and learning the algorithms is not so easy. So learning curve is very steep. So if you are not conversant with the neural network, if you are not conversant with the NLP techniques, or then the learning takes time. So if you're familiar with them, slightly there is a better chance. And most of the algorithms or the larger set of algorithms are available in Python. So people who are conversant with the R or MATLAB, okay, for them it takes some more time. Further, you have to work a lot on the weights, layers, architecture, number of layers, size of a layer, what functions it to be used. So identifying correctly these things is another challenge for its users. Then fine tuning is another aspect that you have to focus on. So learning curve is slow. Complexity of model makes the people to work on many parameters, and model becomes very complex, and difficulty is in explaining why you are choosing certain parameters and what is a possible outcome of those things. Another problem that is there with the deep learning algorithm and the machine learning algorithm, if you see that problem can learn something which may not be appropriate. So models achieving impressive but ultimately useless performance by learning spurious correlations in the training data set. So something it may learn which can result in embarrassment to the organizations, okay, or it can result in a totally wrong policies finalization. So it can, because it is it all depends on the kind of a data that you are having. So if you are not careful about that thing, your results could be quite bad. For example, we'll just take this case of this is a classic example. So I'll just take this one. So this is an example of shorts without stripes, okay, is a query, okay, and the searches were performed for Amazon, Bing, Google, etc., and what results they are giving, okay. So if you are using AIML, then what results it is showing. So the query is for the short without stripes. So this is what Amazon gave the result, short without stripes. So what we see here, there are shorts with stripes only, right? So the word without has been missed here. In case of a Bing, you can see this is the result by Bing search engine. And short without stripes, this is the result given by Google.
It looked totally opposite, ma'am.
Yeah. So this was the classic example actually. It means when you are giving your searches, because see, without has been taken as a stop word kind of a thing. So it must have been removed. So they are showing these results.
Completely different.
Yeah, this is a classic example. What can happen if you are not careful while using, and whatever results are coming, you just take them as it is. Then this is the danger of using.
Yes, ma'am.
So we call it as a clever hand effect. And what clever hand effect actually is that you are learning something wrong. So this was actually, Hans was the name of a German horse, and his trainer trained him for mathematics, that it can add the numbers, and if you add the two numbers, it will tell you the correct result. But actually, he was actually following the instruction or symbol or the signs shown by this trainer.
Okay.
So, and
That's very interesting.
people thought that horse is intelligent. Okay, so that is the problem with this kind of approaches, that learners may learn something wrong, and from the training sets, which may be not noticed by you that why it is happening, but this can happen. Okay, so this is the case. So it's bad for business when you're spending on the application of an NLP based some searches and you are getting the result totally different. So this GitHub repository is all about that thing. And on a lighter note, finally, the translation can also go wrong. So people must be familiar with this song, Behne De Mujhe Behne De, okay, which has been translated as totally very offensive things. Okay. So if something is being done by automated approaches, one has to be very, very careful that what you're getting is what you are expecting or not something else totally. So not everything is gloomy. There is a optimism. Only thing is that we have to be careful while using the deep learning methodologies. This is a new technologies which is being made available to the researchers, scientists, and all. This is going to stay here, as I believe, because a lot of data is being generated, and people, if wisely use these tools, okay, they can develop very good solutions and solve many of the long-lasting problems in NLP. Which even if you can see that even the machine translation we have not achieved to that extent. It doesn't give always the desired translations. These are some of the references which I have listed, not all, some I put there, but this work is, I would say, has been only the compilation of work which has been done by different researchers in the area of deep learning for NLP applications. So with this, I end my talk.
Thank you so much, ma'am. I mean, I have no words to say because the same feelings as I'm having. I think that all participants are also having. Actually, ma'am gave so deep insights for this NLP in the data science, starting from what is NLP and what are the differences between MN and DL, machine learning and deep learning, what are advantages, disadvantages, then distributional word vectors, natural language modeling, neural word embeddings, GenSim library, COBOL and skipgram models. Then Madam discussed the codings for word embeddings, and then how to remove stop words, data aggregation, data frame creation. Then Madam showed vector space model implementation of search engine, word to vector, word to vector embeddings, then character embeddings, then in which Madam showed that out of vocabulary word, how we do that, then pause taggings, so many things Madam discussed in detail. Then Rnn variants, Madam discussed Lstm, how this works, and then JRU works, then Rnn extensions, and so many things Madam discussed for this RNN based NLP applications, machine translations, then RNN based frameworks. Similarly, with the recursive neural networks, NLP applications, parsing leveragings, then recursive autoencoders, reinforcement learning, policy-based, value-based, and model-based, unsupervised learning, deep generative models, GAN models, and how this LSTM in generators and CNN in discriminators work. Similarly, like autoencoders, deep autoencoders. Then NLP platforms, Madam discussed in detail. Then how Madam showed how encodings with the one hot. So then TF, so many frameworks Madam discussed, and we really got so much knowledge, Madam, really. And lastly, Madam gave how the limitation of the deep learning and the problem has been coming when we solve the applications with the ML and DL, that is the clever hands effect. And finally, Madam gave a very classical example that how this deep learning and machine learning can give the bad results. So if I summarize, I have no words, Madam. They have given us so deep knowledge that how this NLP has been working out. So I would like that if any participant might like to share his experiences or experience, because from my side, like I'm highly what to say, I'm like the things were so cleared in my vision now. So ultimately, I'll try to go for this NLP to dig out the problems what Madam shared, finding out those topics, and then really finding out some challenging problems for my scholars. So any participant who want to share his experience.
Thank you, Dr. Priyanka, and all of your team. I think it was a quite detailed, so many topics, as I have said, may have been covered. The primary idea is that people will get familiarized, and those who want to work, they will identify particular models which will suit for their application development, what modification they can do. And as we see that you don't have to start from the scratch, you have got many pre-trained models also. So trying out hands on those models could be a good step.
Yes, Madam. Yeah.
Madam, how to develop a new algorithm based on existing algorithms?
See, what I have mentioned here, that there are different models. Okay, it is a neural network architecture. So what you want to achieve from the neural network architecture, you actually reconfigure accordingly. For example, if you remember your neural network, okay, we just talked in ATs about a hidden input layer, output layer, and a hidden layer. Whereas when we came to the era of deep learning, we said that there are going to be large number of hidden layers. Okay, that means you have got an input, you have got an output, and in between you have the hidden layers. How you are organizing these hidden layers? Okay, what is the functionalities you are putting in your nodes? Okay, that determines the appropriate algorithm. Then how you are applying the functions? Okay, the gradient functions which you are activation functions which you are applying. So because deep learning, haven't gone in detail in the deep learning, how it works. Okay. So as we talked about the CNN, we said that we take the input, we get the output, and that's all. It is not passed on to the next level. But when we talk about the Rnn architecture, what we have done, we have taken the input, okay, then we have taken the nodes which are passing their input. The given node is taking the input from the previous layer node also. Okay, previous outcome from the same layer. How you're organizing your nodes, that is important here. So that is how your algorithm will be actually working.
Yes, ma'am. Thank you very much.
Thanks.
So I think that
Maybe there will be some specific lecture on deep learning also.
no, ma'am. The lab session is there, hands-on session.
If
So
the
might be they
hands-on
will be
session, even
covering.
if it is there, people can try out, because if you are modifying the number of layers, their organizations itself, that itself leads to different architectures.
Yeah. We have, madam, in afternoon. That lab session is there. So with this,
Thank you very
ma'am.
much, madam.
Thank you. Thanks a lot, Dr. Priyanka and your team. And I congratulate for organizing, scheduling very important FDP for the benefit of the participants. I'm sure they will get good exposure.
Yes, ma'am. Yes, ma'am. Really. And by listening the things from you, I mean, though extensive in a manner, the topics have been discussed. So I think that many of them have got an idea where they have to float now. And I really thank you, madam. You have given
Thanks a
so
lot.
many visions to think about on the problem in the NLP. and that has been helping so many scholars here right now, and already they have been working with their problem. So, Madam, thank you again. Thank you for coming.
Thanks a lot. So I take leave.
Yeah, Madam, yeah.
Okay.
So, dear participants, as you have